Hello, welcome to Ekidel. We are trained future civil and structural engineer. My name is Justice Kumwaka and I am your instructor. Basically, it's actually a long time and all that. That's because I was kind of busy at sites and all that. But for these few months, I'll be free. So I'll be making more videos with you guys and also sharing some few things with the younger engineers too. Okay, so today, looking at my screen here is one of the projects we are just constructing and all that. So this is a flat slab design, and this is an office building, office complex having which is 5 floors, basically 4 floors, and all that. So as you can see right now, it has a raft foundation and all that. So this is fully a slab raft without column drop and all that. So today's lesson, I'll be showing you how to insert wind load. Most people still find it difficult on inserting wind load. Most people tends to impute higher parameters for their wind load and all that. So today I'll be breaking down everything about wind load application on this software Protastructure and some inputs that if you cannot get, you are free to leave them vacant and all that. But before we begin, please subscribe to our channel, Ekidel. And if you are a new subscribers or old subscribers, consider joining Ekidel mentorship training or Ekidel membership here on YouTube. I know that Ekidel mentorship training is a one-on-one training where we train you from scratch. I know that. Looking at this right now, we will then begin what we have for today, which is applying wind load to your structure. I'll be telling you the principles and everything involved in wind load to a structure and all that. Then also, we have currently launched a new channel called Ekidel Energy. Now, Ekidel Energy is focused on training the younger engineers or engineers that want to venture or go into the oil and gas industry or the energy industry, knowing that structural engineering or civil engineering also have major roles to play in oil and gas sector and all that. So on our coming videos, we will be showing you some videos that we are posting on our Ekidel Energy channel. So if maybe you want to get that too, you can subscribe to that and then begin to have experience and also learn some softwares that are used in oil and gas sector or offshore engineering and all that. Softwares like Aviva, E3D, which is Aviva Everything um, E3D. And then we also Tekla Structures and SAX software and other professional approved standard softwares that's to be used for the oil and gas sectors and others. Okay, that's fine for that. So with this now, we will then, so once you have your structure, like I said again, this is the current structure we are currently into. That's why I've been free, sorry, I've been away for a very long time now and all that. So you can see if you check on our design status here, sorry, review, then design status here and all that, you can see that this has already been designed for and all that, and we have all done the structural detailing for this building having a slab raft and all that. Okay, that's fine. Now I'll be using this building to perform a master class, but it's going to be a paid one and all that, although I've not yet started that, but I will tell you guys when that will begin, either this month ending or anytime this month. But it will be a paid master class on flat slab design and other kind of structures which are complex and all that. So it will be just 2 weekends, Saturday and Sunday, and we are done with that. So if you want to join that paid master class with me, you can click on the link when that video is being posted this weekend. Okay, that's fine. So with this now, to now apply your wind load on your structure and all that. Now, the first thing that must come to your mind is, when do you apply your wind load to your structure? Now, wind load to a structure, or wind load, is applied on any structure that is more than 10 meters high. So once your structure is more than 10 meters high, it is advisable that that structure is should be applied a wind load, because at 10 meters high, every at 10 meters high, a structure at that height is going to encounter wind effects. But if your structure is below 10 meters, for example, you have 8 meters, 5 meters, you can ignore applying wind load, but on one condition: knowing that there are some countries that experiences wind effect a lot, like hurricane and all that. Hurricane, and some countries too have a very high level of wind speed and wind seasons and all that. Countries like Belize in Southern America, where they experience hurricane. Countries like Dominican Republic. In fact, once your country is within the Caribbean region, even if it is 1 meter high or 2 meter high, it is advisable you apply wind load to that structure. But for countries that experiences normal wind effects, for example, countries like Uganda, Tanzania, Uganda, Tanzania, Nigeria, in fact, almost all African countries that experiences normal wind effects and all that. When your structure is above 10 meters, that's only when you are to apply wind load on your structure and all that. Apart from that, at applying wind load to that structure that is below 10 meters is like you wasting the wasting material for the client, and also increasing the cost of that structure for that client, because what it means is that the wind effect which you have added, that have now cost a bigger section of members to your vertical members, which are like columns and walls, since the building will not be exerted to any wind effects, invariably you have just wasted your client's money. So it is advisable to make sure that before you apply wind load, your building it's at least 10 meters and above. And what does it mean? A three-story building that is 33 meters headroom is not advisable to have a wind load. Basically, wind load application for a structure, for buildings actually starts from 4 story, because knowing that from 4 story you are almost encountering about 11 meters, 12 meters height. That's the minimum you can have, and all that. So looking at this right now on my height of building here, height of story, you can see that my total height of story here is 21.9 meters. If you check the last floor here, which is the fifth floor, 29.9 meters. 21.9 meters, which is already twice the level at which I'm to apply wind load to a structure. Okay, so now that you have known when to apply wind load to your structure and all that, the next thing now is, how do we apply the wind load? What parameters? How do I get my parameters? Because most times it's very difficult to get your wind data or wind parameters and all that. Most times too, you get that by what? Using a compass. Yeah, if you have okay, most people used to use Google, or yeah, Google helps that a lot. But what you do when you're using Google for your wind speed, you don't take the immediate wind speed to use for your design. You do at least what they call like forecast. You have to look at, for the past 5 years, what kind of wind effect has happened at that particular area you want to erect that structure. For example, if I want to erect this structure right now in Lagos, Nigeria, or I want to erect this structure in Nairobi, Kenya, or I want to erect this structure in Kampala, Uganda, what I would do is that I'll go to Google and ask, what is the maximum wind speed that have occurred if I'm using Lagos in Lagos for the past 5 years? Google have those datas, all right? So it will bring out those datas. I'm just saying this is the e- um, easiest way to get your wind data if you cannot get it the from the government. All right, so this is the easiest way to get that. So how you now answer go, what is the maximum wind speed that have occurred in that city? For example, Lagos or Kampala in Uganda or Nairobi, all right, or in Accra in Ghana. So when you have checked all this now, when you have gotten the maximum, you then ask again, what is the average wind speed that have occurred in the past 5 years? All right, you keep that, you write that one down too. All right, you can ask again, what is the maximum or highest wind speed that have occurred in the past 2 years, and all that. So by the time you have gotten a 5 years data, all right, you look at it. When you have looked at it, then you can do some little calculation. You can choose to take the highest of that value, or you add them up together and take the mean and all that. Okay, that's fine. So with that now, but if you can lay your hands on the wind data around that region where the site or the city where that building is to be erected, then that is fine, right? But I'm just telling you that this is the way they get wind data. They normally take 5 years backward. Most times they take 10 years backward, but the best is to take 5 years backward. Okay, which is 5 years record. Okay, that's fine. So with this now, we will then move. So once you have known that, then you then go into to applying your wind load. So in that now don't forget, Google can give you your wind load in different SI units, like units and all that. So you have to convert it to meter per seconds, because that is what this software, Protastructure, uses for its wind speed. All right. So if maybe you are having your own in kilopascal and all that, you have to convert it to meter per seconds. Okay, that's fine. So with this now, you then come to what? Loading here. Now, when you come to loading, after your modeling all your structures and everything, you have applied your wind, you have applied your height of story and all that, then come to loading. Now, when you come to loading now, before this time, you must have picked the design code for your wind. Okay. Now, if you have not done that, you come to settings here. Now, under settings, you will see codes and all that. So you can see now under settings, now you are going to see codes. All right. So on this code now, if you have to come and choose your your wind load code here. Now, in this case, I'm using Eurocode. That's what I use, because BS code is already obsolete for use and all that. Although most people still use it, but for standard companies, or if you're doing designs for international bodies or companies that uses BS code before, they will require you to use Eurocode, because that is the code that supersedes BS code. Okay, that's fine. So with this now, you have to now come here and then pick your code. So even if you're in a country, different country, if you are in Canada and all that, you might not see Canadian code here. So I'll advise you choose AC and all that, right? US code, okay, and all that. So if you're around American region and all that, you are to use American, which is US code and all that. But for now, I'm to use your European Union code and all that. So they have different codes here too. Okay, that's fine. So I will then come here and pick this. Now, if your structure is below 10 meters, all right, what you do is to come here and say, don't use wind code. Automatically, it will erase everything about wind load on that structure. All right. If I say okay now, or just say okay, you can see that the wind code area, sorry, is just blank. That means that you are not designing with what wind load on this structure. All right. But since I have to apply wind load on this structure, I'll come here and uncheck this and then pick the code which I want for my wind load calculation. Okay, that's fine. So with this now, then come and do what, say pick here. So on picking now, you can see that earthquake, which is seismic load, is not applied because this structure is in Nigeria, Lagos State. So I'm not going to apply earthquake or seismic load because most African countries don't experience anything like seismic or earthquake. But I've been getting some comment that I should teach on seismic design because we have done more designs in countries like Canada, Germany, and all that, Portugal, Poland, that experiences earthquake and all that. So I'll be doing a video on that this month, okay, on seismic and all that. Okay, so with this now, once you've picked your load now, your code for your wind load, you then come here and do what, say okay. Now, on saying okay now, that doesn't mean that you have applied wind load on this structure. You have just picked the code that's going to guide you on your wind inputs, all right? Wind load inputs, okay? So with this now, you then come here and say wind load, wind and story load, okay? So once you click on this place now, you are going to see this interface, okay? Now, on this interface now, you are going to see, I'll just do what? Reset. All right, I'll just reset. I know that. Reset coordinates and all that. Okay. Then once I reset now, all right, once I've resetted, then I'll then come here. But you can choose not to click on this. It doesn't mean anything. But if you have applied before, then that's when you can do this. Okay. Or you can say ignore it because once you put a new code, sorry, a new value, it will just what override the other one. Okay, that's fine. So this is, you can leave this one here. So once you have come here, all right, just click on this letter that says wind load calculator. Don't enter any values here. These ones are gotten automatically. Don't enter any values here. So come here right now and do what? Click on wind load wind load calculator. Now on this place now, once you have come to this place, I know that the next thing to do right now, you can see the first thing here is says what? Parameters, right? You have the first thing here, general, which is parameters. These parameters consist of what? Wind speed, which is basic wind properties, which are the wind speed and the minimum wind pressure, and then the primary angle. Now, let's now begin. Now, on this place now, you can see that your basic wind speed is measured in what? Meter per seconds. Always put an eye on the units you are working with, all right? Now, you can see now, on your default, you will see 33.5. That's default wind speed in Protastructure and all that. So on this now, you have to impute your wind speed. Now, your wind speed now doesn't mean the country wind speed. No, it is the city or the area or the province where this particular structure you are designing for is going to be erected or constructed. You have to know the wind speed of that particular region and all that. Now, for example, city like Lagos, Nigeria, uses the same wind speed with UK, all right, with London. They use the same wind speed with London and all that, which is 30, all right, 30. It ranges from 30 to 31, 32. Okay, that's fine. So you have to know the winds. I've already said before how you get your wind speed. You have to check for 5 years back record. All right. Then you don't have to check your mean, calculate log, just you can, but the best is to pick the pick the maximum. For example, if I have checked now maximum wind speed I've ever occurred in Lagos State, or let me say in Kampala, Uganda, Kampala, which is the capital, or yeah, it's in capital, yeah, Kampala, and inside the Kampala, yeah, I think Kampala is a city, or yeah, it's a capital. So let me say I have like 15 or something, or let me say 25 or something, sorry, 25 or something. All right, I won't put that value there. I'll check again. What is the, okay, for the past 2 years? I'll get the value. Let me say I get 23. For the past 3 years, let me say I get 21. For the past 4 years, let me say I get 19. All right. Then for the past 1 year, okay, which is, yeah, 1 year. Let me say 1 year. Let me just say 1 year ago. Let me say I get like 30. Right. So with this now we have 30, 25, 22, 19, and I think 21. Yes, I know that. Now we have five values, five wind speed record values for the past 5 years that have occurred. All right, each year. Now with this now, you can choose to go with the maximum that have occurred so far, or you can choose to add the whole values together, divide it by, let me say, but like that to get the mean. Although that will be in excess, I know that. So what most people do, if you cannot get the direct wind speed of that particular area, because each city, each area have, each region have their wind speed, but this is how they get their wind speed is from the past records. Then they now do and get the mean, which is the average, all right, which is the average, because they can't give you the wind speed at that particular day. You can't use that particular wind speed to design for your structure, because what happens, what if tomorrow, the next day, the wind speed changes, because that day might come with a very high wind speed or with a very low wind speed. Then tomorrow comes, but if you have checked for the past 5 years record, you have seen back to back, or 7 years record, you have seen back to back what has happened and all that. So in all essence, there is no way any other higher wind speed can occur more than the record you have checked, because you check the maximum. Most times I even stretch myself to go, what is the maximum wind speed that have ever occurred in, let me say, in Kampala or in Lagos or in London. But be careful with that question, because when you ask that question to like Google, Google give you the highest wind speed that country, that city, that region, that province have ever recorded. Most times you'll be seeing let me say 50 or 75 wind speed. But don't be rushed to like get scared. Look at the dates. You see that that date is around 1830, around 18th century, and it is very very possible for that kind of wind speed to happen, because 18th century, let me say 1820 to let me say 1820, yeah, 18th century, early 18th centuries, most major cities like New York, London don't have those tall buildings that they have today. Those tall buildings causes wind obstruction, and that they help to reduce the wind effect or wind speed of a particular region. So those days in the 18th century, there was no obstruction at the atmosphere that is obstructing the wind speed. So if any wind record was taken that period, what happened is that they will have a very maximum wind speed because there was no obstruction. But coming to 20th century and all that, you can begin to see that engineering begin to do what, harness the earth for man's comfort. They began to build mega structures, and all these things began to cause obstruction within the atmosphere and within the environment. And with this happening, the wind speed of a particular regions that have those highest buildings begin to break down, and then we begin to reduce the we begin to see a reduction in wind speed and all that. So don't be too quick to use the maximum that have ever occurred in that country. Okay, so always check 5 years back record, or at maximum 10 years back record. Then sum them up together and get your average. Okay, that's fine. So with this now, but if you can get your wind speed in your like from your government, then that is fine. Okay, that's fine. Although every code has that too, but I think most countries don't have their own code. I think only in Africa, the only country that has their own code is South Africa, that has their own code based on their country. Other countries like Ghana, Nigeria, and all that, they are still using um, UK standard. All right, I know that. So with this now, so once you've checked your wind speed, let me say that the wind speed now of Lagos and all that is 30 and all that. So I put my wind speed there, which is 30. Then this place that it says minimum wind pressure in kilopascal, minimum wind pressure in kilopascal. Now, I always tell that you leave this one as it is default. Now, what does it mean? Minimum wind pressure. All right. What it means is that the minimum, the lowest, the minimum wind pressure that occurred in that particular area. So just leave it at 0.5 and all that. All right. That doesn't really take any effect in your structure. So leave it as it is. Now that it's just like someone, it's just like you are standing and someone come to push you or come to slap you with just one finger like this. It doesn't make any effect than someone slapping you or punching you with one full, no, with the five fingers being folded. That makes some effect, right? So just leave it as it is, okay? That's fine. 0.05. Now, this one that says primary wind angle, always leave it at 0. Don't put any angle. Once you put an angle, what you are trying to say is that you have studied the wind and you have known that the wind is coming at that particular angle. For example, if you put here angle 45, what you're saying is that you have studied the wind and the wind is coming at angle 45, which is never impossible because no one can measure the angle at which the wind is coming from. Wind comes from different angle, right? So since wind comes from different angle and all that, it is advisable you leave it at what, 0. All right, at 0. That means that it can come from any angle. It can be at angle 45 now. Next time is at angle 30. No, just different. So you cannot measure the angle where it's coming from. Okay, except you are directing the wind. Except maybe during practical, where you can direct a wind to pass through a funnel measuring the angle, then you cannot measure the angle, that kind of thing. But it's very hard to measure the wind angle. Okay, that's fine. So leave it as what, 0. Now here that says terrain and surrounding, all right? Terrain and surrounding and all that. Now on this terrain and surrounding now, this is saying what? Hill height. Now what does a hill height means? Hill height. What does it mean? Now hill height now is like, no, before I tell that there are some values which I will tell you to leave at default because it's difficult to get that value and all that. Now, what hill height, just like the name hill. For example, people that live around the mountainous region where there are mountains surrounding them, at that particular place, we know that the wind speed of that area will be minimal. Why? Why? Because there are already obstacles, which are the mountain surrounding the air, the environment, which will help to break the wind speed or the wind pressure coming to hit on that structure. So now they are asking you, is the height of the hill more than the height of your structure? And all that. Don't forget the height of this structure is 21.9 meters. All right. So let me assume that the height of a hill around the area is 50. What it means is that my structure is almost more than half of the height of the hill. What it means is that when the wind comes, all right, when the wind comes, it will first hit on when the wind speed come, it will hit on on that hill first. Then it will now what? Divert. Now that diversion of the wind have that obstacle, which is the hill, have already broken down the wind speed. So for example, if the wind speed that was coming was around this 30, all right, by the time this 30 meter per second wind speed hits that hill or hit that obstacle, what it means is that it will break it down to even more than half. So at the end, you can see that what is coming to hit your structure might be around 15 or 10, which might not have much impact on your structure. That is why if you see most of these massive hotels, massive structures, and all that, all right, what they do, if there are no other tall buildings around the vicinity, around the area, they tend to plant trees that has a very high, that grows very high. You would think it is just for designs. No, it's not for designs. That is the advice of a structural engineer. So when you are designing for buildings around, now this thing I'm explaining now is the same thing I will explain for this and this. So and also this. So I might skip all these things. I won't explain much here. So make sure you understand this I'm saying now. So you see that most hotels or most tall buildings, if there are no tall buildings around, for example, if you are going to build a 10-story building now in the city like New York, you know that your 10-story building will like look like as if it's a bungalow because they have other tall buildings, 60 stories, 80 stories, 70 and all that, countless. So you putting your 5-story or 10-story, it will be like a dwarf in that area. So when there is a wind speed, you will see that your building might not even experience any wind speed at all. There is no wind load that will hit on your building because the surrounding structures, the surrounding buildings that are already at that area, those taller ones will help to receive the wind pressure, and before it gets to your building, the wind load have already been broken down to pieces. So it will not have any effect on your 5-story building that you have. But if you are building, for example, you're building a 10-story building on a very flat ground, let me say a village, right? A rural area, a desert, or a place where all other buildings there are just bungalows. Only your 10-story building is standing high. Know that it is your building that all the wind will target because that is the tallest building around that place. Now, what does it mean? Most buildings, 10-story building height building is more than 30 meters above, right? For example, if you're saying 3 meters per floor times 10, that's already giving you 30 meters above, all right, height. So what does it mean? Why other buildings are like 3 meters and 4 meters, yours is 30 meters. You see that that structure will have enough wind effect on all angles of the buildings, all right? So in that particular region, you, the structural engineer, yes, you have designed that structure against the wind. That's fine. But you still advise your clients and all that to plant trees, to plant trees around like some distance away from the from your building, either hotel or office, to plant at least trees. That's why you see that most buildings around the coastal regions, around the sea areas that are a bit high, most people tend to plant trees like coconuts. Sometimes you can see very tall flowers and all that. Now, these things are not just for aesthetics. They are there to help to break the wind pressure, knowing that at that region there is a very high, massive wind speed and all that. Okay, that's that for that. So this is the hill height. Now, this x here, this x you're seeing here means what is the distance. I told you that you are going to advise your clients and all that on planting obstructions like trees and all that. Now, the next thing that they will ask you, at what distance? If the tree or the plant is close to the building, very close to the building, what happens? The roots will damage the foundation of that building or might even cause cracks on the wall. So you have to give a reasonable distance far from the building and you have to calculate that, okay? No, that kind of stuff. So you have to give a distance. That's what this X here is saying and all that. You give a distance and all that. Now, if you're using the tree method to be able to break down the wind speed, that's if you're building in a rural area and your building is the highest there, then you have to meet the horticulturists. They know, they can look at the plant and tell you the length at which this roots of this plant can grow, because they studied plants, right? I know that. Botany, know the kind of stuff that studied. I know, yeah. So you meet them. And so any plant you are using, you must not be a plant that will have, because some trees or some plants has their roots, they will flow down almost 3 meters, 10 meters down. So you have to be guided on the kind of trees you plant. Okay, that's fine. So that's what this X is saying. What is the distance of the obstacle before you're building? Either you're using a tree, or you want to do an artificial hill, or no, what is the distance to your building? Okay, and all that. Now, this LD now, the LD, what is it saying? The actual length of downward slope of the wind. For example, now you have planted the trees, right? So when the trees are coming now, so you have or let me say you have obstacles, or you have trees, or you have other tall buildings around the region higher than your own building. Sorry, yeah, correct. Now, as the wind hits that structure, what happens? It's going to refract down, right? There's going to be something like this. It will go like this. It will go as if it's a wave like this. So this L over D now is saying, what is the length of the downward slope of the wind direction? Right? I know that. So, but this one is very hard to get. So leave it as what? Default. Okay? This other one too, which is the LU, leave it as what? Default, because this is saying the upward. So leave it as what? Default. Like I said again, and like earlier, you can leave some as default because they are very difficult to get. So now you can leave this 50, this 100 and 150 as what? Default. At default. But if you know this, you can put it, which is the distance of the obstacle. You can put that one. You can put this. But if you don't know, please don't worry yourself on that. Leave it at default. But these three here, which is the basic wind properties, are the ones you cannot leave default. You have to impute the exact wind speed. You must impute the exact wind speed, else that building, that structure will have an issue, which can lead to collapse or lead to tilting. Okay, that's fine. So let's now move to what? Total building height. Okay, for example, you can see that ours is already what? 21.9 meters. Okay, now that 21.9 meters is not all about the what? The It's not all about the height of the structure. The the actual height of structure is 21.3 meters. Okay, now the other value you're seeing that makes it up to 21.9 is what? Is the DPC and all that. The DPC. Now the DPC of this building is 600 millimeter. So by the time you add 600 to this 21.3, you will see that it's what? 29.3. So by the time you add 0.6 to this value, you'll be having what? 21.9. That's how we got it. So anything below the ground level, is not counted. That's why you cannot see it counting here, because wind does not affect anything below the ground level. So that's why you can see that what they are taking here as a building height is just the one above the ground level. Those are the superstructures. Okay, that's fine. So the next thing now, you can see that we have what? Hue type. Remember I told you guys said that for about hue and all that. So hues are classified in different ways. If you can see that, cliff and all that, but our advice just leave it as what? Just cliff here. Leave that cliff. Then for this now, which is the upward and downward wind. If you don't know how the wind of that area operates, leave it as what? As upward wind. Upward wind have more effect than downward wind. So if you don't know, please leave it as what? Upward wind. That's fine. So then these other ones here, leave it as default, as default. Then we then move to this terrain category. Now this terrain category now falls on the place where I was telling you guys that if you are building your, let me say, 5-story, 10-story, you're building in cities like New York and all that, those things have effects. And if you're building in a rural area, those things too have effects. So if I click here now, terrain, they will show me this. You can see this category 0 means that it is in a coastal or sea region, which is exposed to open sea. And in this particular area, there is a very high tendency, very high wind speed operates in this area. And so you must be careful when you're choosing your category. Now, the best at default is to pick what? Category 4. Now, category 4 are cities like Nairobi, which is in Kenya, cities like Kampala in Uganda, Lagos in Nigeria, Port Harcourt, Accra, those kind of cities. You can choose category 4 and all that. That's because there are already existing buildings around the city. It's a developed city. So there are already existing structures that will break down some wind speed, like when the wind is coming. All right, and that's okay. That's fine. But you can see other categories here, so you must be very careful when choosing this category. If you're choosing category 0 to category 3, you must be very careful and it will be accurate. You must not make it if your structure is found in any of this place. For example, category 1 is saying flat area with what? Negative what? Vegetation without obstacle. What does this mean? For example, if you are going to build in a city like there are cities in US, in American, like this there are villages where what you can see there is just you can count the number of houses, and those houses are less than 4 meters high or 5 meters high. All you see is flat grassland and all that. So if you're building your structure in that kind of place, know that there will be high tendency of wind attack on your structure because everywhere is open. So like everywhere is open, so it's like a playground for the wind. So you must be careful, all right, on doing that. So with this now, category 2 is saying about what? The area with low vegetations and all that. Now, this kind of place now can be places like Saskatchewan in Canada, knowing that that's like a place where when people are retired they go to. So it's like it's not that developed. And so I'm just saying, like based on you now in your own village, right? Yeah, not well developed, but there are buildings around, right? Not well developed, but there are buildings. Although the buildings are not too high, and all that. Yeah, but it's like a rural area. Category 4, right? Areas with regular cover of vegetation or building with with isolated obstacle with separation maximum 20. No, this category 2 and 3 are almost the same. They are still around rural area and all that. Now, category 4 is what is more popular, is for cities. I already mentioned them. Cities like New York, Kampala in Uganda, um, Ottawa, Lagos, Nigeria, Port Harcourt, Abuja, Nigeria, Accra, Nairobi in Kenya, all these kind of cities, right? So you can pick this category 4. That is more popular that what most people use. Then come now and once you choose your category, it's if you choose this category 0, what you expect in your structural members will be very massive. A column that's meant to that naturally would have fit that structure if you choose category 0. Let me say a column of 450 diameter or 450 by 450 column, square column, can pass through this place. But if you choose category 0, you can be expecting column size of 650 by 650. That's because of what? It has experienced enough wind attack. That kind of stuff. So I'll choose this because this building is in Lagos. So I'll choose this and I'll come here and say what? Okay. So on this now, automatically you will this is like this is the factor of safety for that. So you can leave this. This comes with the code. You can see we are choosing what? Eurocode. So I will not have to change this. Okay, that's fine. Now you can see our wind result right now. You can see that 0.84 kilonewton per meter square. And that's a pressure. That's a pressure. Now we are not done yet. Then come here that says what? Structure properties. And all that. On this now, you have to come here and choose the kind of structure. In this case, we are designing an office complex, which is a reinforced concrete building of what? Flat slab. So I would choose reinforced concrete. If you're doing a steel, like a warehouse building, please choose steel structure. Don't forget that. If you're doing a composite structure, which is the mixture of steel and concrete together, then choose composite as your building category. Now, if you're building RC towers or chimneys and all that, now what this thing means is that you can see the Liberty Tower, those kind of structures, Liberty Tower, those kind of concrete structures that you see in India, in France, those kind of in America, those are what RC towers or chimney, those kind of stuff, those statues, those kind of stuff. So you choose this. But for now, we are designing for a reinforced concrete building, which is an office building of what? 4 story actually. So I'll come here now and then choose here. So once I've done this now, the next thing I'll do is to do what? Apply. All right, I've applied. I've applied. So now that I've applied now, I've applied the load there. I'll then come here and say what? Okay. I'll then come and do what? Say save. So with this now, this building is applied with a wind load of 30 meter per second wind speed. I know that. Okay? And having a pressure of 0.84 kilonewton per meter square, which we checked. And that. So you can see that we have now applied wind load on this structure. Now, if I design this building without wind load, you will see that the size of these columns will do what? Might tends to decrease, because this is actually 450 by 450 and all that. Might tends to decrease and all that, or the reinforcement sizes might tends to do what? Reduce, because there is no wind effect. All right. Now, as we have applied wind effect here now, you will see that the reinforcement will tend to do what? Increase, and most of these sizes might be adequate. Some might do what? Want you to do what? Increase the size of the section. The same way, if I apply seismic now on this structure, that's earthquake load on this structure, most of these columns will fail. Most of them will fail. That's because earthquake load governs a lot when it comes to seismic design. Most of these concrete vertical members will fail. And I must have a good confinement around the base. All right, and also when during detailing, you know, well, seismic is a different lecture altogether, because when it comes to earthquake engineering, it's not just about designing. What governs too is detailing, because the way you detail a normal building without seismic effects or seismic load is different from the way you detail a building with seismic load, or which you apply seismic load to, or that are going to experience earthquake effect, is way different. You are going to consider bidiagonal reinforcement. You are going to consider the link spacing is very, very vital. The link spacing between the beam and the column, the joints, all the joints, anywhere you have joints, in fact you must critically follow the principle of detailing seismic structure. Joints are very important, because when you once your joint does not follow the principle of seismic detailing, what happens is that as there is vibration, it will attack the joints first. It is the joint that it attacks first. Now, once the joint fails, every other members to that joint will do what? Will like fail. So that's why joints between column and beam is a vital case you must deal with. The confinement around the foundation is a vital case you must deal with. If you don't have confinement, you must have to introduce confinement around the base. Well, that will be a different seismic design, will be a different this altogether. So for this now the first video I'll be teaching on seismic will be on using IBC code, which is the American code, and then I'll use some real life data of the ones we have designed before for some clients in Canada and US. I'll use the data and then teach you guys. Then we'll then move on to Eurocode 8, which I love so much. Eurocode 8 is very nice. I love it so much. I also use a data too and then teach you that too. Okay, that's fine. But if you want to gain more on Ekidel, I always advise you enroll for Ekidel mentorship, which is a one-on-one training and on what structural designs and all that. But Seismic is not included. Seismic is a different mentorship on its own. It's like a coaching on its own, which has different payment on its own. All right, because it's kind of it takes lengthy time to so we don't include it on our mentorship. So that's a different game altogether. Okay, that's fine. Then if you also want to join the masterclass for this building, which you're seeing here, which I'll walk you through from the plan, from the building plan up to this stage, and then finish design. I'll tell you the principle of flat slab and all that, what you're to look out for around the middle strip, column strip, and all that, and how to also show you guys how to choose your reinforcements. Because when you do that, it will give you different reinforcements and all that. So I'll show you how to choose your reinforcements between the column region, middle region, knowing that we are going to use the FE analysis for flat slab. So I'll be showing you all that. Okay, that's fine for that for now, because we have already, this is already 52 minutes actually so far. Thank you so much and God bless you. Now, if you have not click on our let me say subscribe to our channel, please subscribe and please like this video. Thank you and God bless you. We love you and I love you so much. See you then. Bye for now. Bye then.